webinar series on data engineering from AFour Technologies. I am your host, Shailesh Gaikwad, for today's session. About me, I have over 17 years of experience in software engineering and data engineering. I worked on multiple BI and analytics solutions using Azure Cloud and AWS. Currently, I work as a technical project manager with AFour Technologies. In this webinar series, in today's session, we are going to talk about uh, how to architect applications to solve business problems using data. And before that, I just wanted to make sure that we are recapping on topics which we covered on day one. So on day one, we talked about data engineering, and before data engineering, we discussed what is data and what is its uh, applications. And when it comes to data, what is big data? What are the three V's when it comes to big data? Then we discussed about data science life cycle and how data engineering component fits into that cycle. And when it comes to as a whole data science life cycle, what are the different roles involved in this cycle? So we saw that how data engineering uh, uh, for how data engineer actually uh, creates those pipelines in order to extract, transform, load data so that other roles can consume that data in order to give some insights or can build some models to solve some business use cases. In
Now,
this,
let's go
back
back
to
to
our slide and let's start with today's session. The session is all about how you will use data in order to solve real use cases. When you're developing your application, you usually develop your database or a place wherein you store all the transactions coming out of that after use coming out when people are using. Some transactions are getting generated and you're storing that thing somewhere, but using that data you can still go and do some engineering on top of it to make sure to get rid of some uh, problems which you're observing when your users are consuming that data. Now, when we talk about data, then we need to understand what are the different sources of data. So the different sources of data when it comes to any application is either two. One is different telemetries which you collect out of that application, and the transaction details or events which are getting generated, and you're storing that thing somewhere. So this particular scenario we are pretty much clear, wherein you are uh, uh, you are actually keeping track of what for example a product wherein you want to store different transactions like what are the ordered items and all that thing. So all this thing goes into your database, might go into some event hubs wherein you're storing all those events, and then you're processing that data in order to find uh, what is the pattern. And when it comes to telemetry, there are two types of telemetry. One is client side telemetry and one is server side telemetry. What do you mean by telemetry is that it's a way through which you are actually understanding how that particular application is getting used. For example, you develop a mobile application, then you want to know what all which kind of users are using your mobile app. Is it Android mobile phone or it is iOS? And then what are the features on those that application people are using? So that comes under usage and engagement metrics. For example, if you develop any product which has 10 features and you want to know whether I want to go and continue my investment in this particular application, so you add some kind of hooks wherein whenever a particular application feature is invoked, it sends out some kind of logs to the server saying that okay, from this user, he has clicked on this feature and he has done some transaction over that. So you collect all this telemetry and you build some uh, uh, visuals in order to get insights into what is happening when it comes to this particular app. For example, there are 10 features in that mobile application, and you want, based on this telemetry, you can clearly see that three are the features which are top features which are getting used by each and every user, and there are next set of four features which are very less used, and there are three more remaining which are not even touched, or people are not even exploring those options. Then you can decide whether to go and stop investment in that developing investment in developing those features. So based on client side and server side, you can get some kind of insights that can help you in order to uh, decide where you want to invest from business angle. Then real time and data, real time health of the data, using the data which you're collecting. For example, there are different kind of SDKs available today. For example, from Azure, we have application insights. Using this SDK, you are actually placing some kind of hooks in your server side and client side uh, application, which actually collects what is happening in background. You can see what was the peak, what was the where you're getting errors or exceptions, and then you are getting those logs, and you're acting on it. You're trying to make sure that application is 100% or 99% available and it's meeting its SLA. uh, so when it comes to real-time health, application inside using SDK, Azure automatically collects this data and creates the visuals for you, which wherein you can just go and monitor what is the current state of your application. Then we have this hypothesis validation third part, wherein you are actually getting direct feedback from your users, and based on that data, you are actually deciding what to do next. For example, it could be you're dogfooding your application for some set of users, and then you're collecting the data. Or maybe second use case could be you're dividing your users, and for one user set you're providing some promo code so that they can just go and purchase uh, items using that promo code, and similar set of users who are actually not given any promo codes, and you're actually observing whether these people are going to your app and uh, trying out same features or not. You might have seen uh, some kind of for example, any applications, for example Paytm, or which gives you some kind of promotion codes uh, at whenever there is a you want to onboard new customers, you want to try out this path, but once that user is on your application, you might not give him back the similar kind of promo codes. So you're actually if you don't want to go from the practical ways, you can uh, create some kind of scenarios wherein you want to check the effectiveness of your marketing campaign. So this kind of hypothesis validations you want to do, you can do this way also. So all these things are getting some kind of, you're generating a lot of data, and then you are actually running some analytic jobs on top of that to check the effectiveness of the campaigns, or the real or monitoring, or doing monitoring on your applications, or you want to learn what are the usage and engagement metrics in order to decide where to invest or where to pause your investments. Do you have any questions on this slide? Okay, let's move to next part. So next part is all about what kind of data we are getting when it comes to your applications. So your whatever applications you are developing, it can generate two types of data. One is structured data, one is unstructured data. When it comes to structured data, it follows predefined data models, and most of the time it's easy to search, and it is textual only. But when it comes to unstructured data, it could be your images, sound, video files, and this kind of data is very difficult to search. Yeah, when it comes to storage, this structured data is stored in relational databases or data warehouses, whereas unstructured data, you need data lakes or NoSQL kind of databases to store this kind of data. When it comes to this part, this data is both generated by can be generated by humans or machines, and then typical applications when it comes to structured data is CRM or ERP systems. And when unstructured data, it could be word processing, presentation software, or tools for viewing or editing media. Examples of structured data, you can see that we have dates, phone numbers, addresses. This all this thing comes into structured data, while in unstructured data you have your text files, reports, audio, video files, images. So now you can understand when it comes to unstructured data, what kind of user scenarios you can build, or what kind of applications you can build. For take for example, people are posting their selfies, right? So using those selfies, one can build an application which actually gets this data and then classifies that data, so that and to declare whether that selfie will be a popular one or not. So this is a simple example I have given, but yes, all this data can help you in order to get uh, to solve help you to solve some business problem, or you can it can
Using
help
those
you to
selfies, right?
altogether develop a new application which you can go with you can go to market to sell it. Now, next, let's start with some case studies. When it comes to data engineering, all you need to understand is that there are different steps involved. For example, you need to ingest your data into your data store, then you're collecting and then working on that data in order to uh, uh, come up with some kind of model version of that data which goes into your data warehouse, and then end users are consuming that data in order to solve some problem. For example, in this case study, this is very simplest form of case study wherein suppose you have developed an application which actually allows users to post questions onto your portal, and then you assume that there are different users who are actually monitoring those questions and they are answering those questions. Now, as a end user, if I am an expert, if I go to your portal and then if for example, I'm a Python expert and I want to learn what kind of questions are raised in Python side. I won't be able to search quickly on your application if you're not categorizing or bucketizing those questions. So either someone has to go and tag those questions into particular bucket, or there has to be some team, backend team, who is actually going and tagging those questions to a particular area. Or there is a third option wherein you can create a catalog of these questions, and then you are running some algorithms in order to categorize this uh, questions into proper buckets. So here you can see that you're collecting those questions, you are putting that thing into some catalog, and then you are running some jobs to categorize those. So you don't. So basically, you don't need to have a backend team, or you don't have to rely on the user who is posting those questions. The moment a question is raised in that portal, it automatically gets tagged in couple of seconds that which area this question belongs to, and that can help the popularity of your application, wherein people can just quickly search the tags and they get what they want. So this is the first case study. Then we have one more case study. This is the real example from my assignments. This was all about sending transactional and promotional emails to end uh, customers. So as you can see in this. case study, there are many stages involved wherein this is this is a product wherein people or and customers come and subscribe to this product, and when they subscribe to this product for the first time, you want to send instant email to that consumer or customer, saying welcome to our service. So this comes under transactional email, wherein the moment you see any subscription, you want to send out immediate email. But there are some kind of emails which goes after 1 day, 3 day, or 7 days, uh, which we call them as a promotional emails. You cannot just go and send these emails to everyone, right? The moment a particular one user, uh, end user subscribes to your application, right? Next day you want to send that user. So when you're running your job, you need to make sure that you have extracted a list of users which uh, which actually is 1 day user, or 3 day new user, or 7 day new user. For those users only, you want to send some kind of promotional emails. uh, what do you mean by promotional emails is that when you get a new user on your application, next day or first day you want to send out him the list of features you he might be interested in exploring. Third day, based on the usage pattern, you want to send out some other next level of promotional emails, that you have already tried this feature, but you can also try this feature. Or 7 days, something more relevant to that particular day, you want to send out. So you can understand that you need to run these jobs daily in order to extract this data. uh, because if you have million users, you can't send this promotional emails to all million users. You want to reduce the set so that they fall under same bucket, that these are the users who are uh, who are one day old, or 3 day old, or 7 day old, right? And there is an interesting fact also, one can uh, consider while creating this list. Nowadays, whenever you subscribe to any service, there is one checkbox which says that do you want to receive promotional emails or not. So this is a very important point one has to understand. So this particular, whenever you create your catalog with this kind of users, you actually put a flag whether he wants promotional email or not. So when you're generating the list for 1 day, 3 day, and 7 day, you actually running your job to extract data from all the users which are subscribed to your database, subscribed to your product. Plus, you are also joining it with the uh, tables wherein you are actually storing the preferences of that customer. So even if 100 users are eligible to get 1 day, but out of that 100, 30 users have mentioned that they don't want to get promotional emails, your actual 100 list gets reduced to 70, and then you send emails to 70 people. In top of that, you can also understand that some people are they say that we don't want to be approached using email or email, but we want phone only kind of interactions. So this that 70 users can also get reduced to 25 or 30. So this can't be done using simple search queries. You need to make sure that when you're dealing with big data, you have those extraction jobs running somewhere, which is creating this kind of list, and you are then sending promotional emails based on the whatever filterings you want to apply. So this was all about the promotional emails. Then we have some different category of emails for which again we need to extract data, right? So extract list of data for which you want to send out emails like you have not explored these features, why don't you go and explore this feature? Or if a particular user has subscribed to your product, saying that I want to pay monthly fee, uh, and you don't want to lose that person. So what you can do is that you extract such users and you send out email saying if you subscribe to our service for whole year, then we are giving you 10% discount. So this kind of emails also, if you want to send, you need to run some jobs, right? And this has to be run daily in order to get the in order to extract such kind of users. And there are some, this is a third category wherein wherein you want to proactively send emails to all those consumers or all those customers whose credit card is going to expire. So if you, this proactive emails make sure that you're not losing that customer because of something which was there in your control. So in time, if you send him this message saying that your card is going to expire, that user might go and just update his credit card, and you can make sure that he continues consuming your services. Then there are fourth set of emails which you want to send out, for which you might need to run some kind of algorithms. Again, this algorithms needs to be configured somewhere in your data pipelines, wherein it runs and sends out recommendation emails to your uh, end consumers, like features and interest rate items to buy based on the past history. So this is not uh, uh, re- based on the real application development, but these are the use cases or case studies uh, post your application is running in production, right? These are the pipelines you build in order to make sure that you are taking it to the next level. So this is one case study, and then we also discussed about this user engage metrics, right? On first slide, this first one, usage and engagement metrics. So I mentioned to you that there can be a scenarios wherein your business team wants to decide uh, whether to invest on some features or not. So any application in background consumes n number of services which are developed again for your product. So what you can do is that you can build uh, different data pipelines in order to get this kind of usage patterns. So you are collecting server side telemetry logs, server side logs, and you're actually generating this kind of pipelines where you're extracting and aggregating what number of APIs got hit and they follow which path. So based on that, you can create this kind of visuals for your business team, saying that this is the path wherein people are. This is the most popular path, and we need to make sure we are continuing investment in this particular path. And then you can also understand that there are different kind of paths wherein user stops after first node. Then you need and if you go deeper into that, deep dive into that, you can understand whether it is because of user experience, whether it is because of faults in your application, people are not moving or not using this uh, path. Then you can go and you can direct your development team to focus on this path. And then there can be some kind of paths wherein after looking at this thing, you see that there is no uh, need to go and pursue this path. So you can decide and you can stop this particular feature. So this is what we call as user journey or user engagement profiling, wherein you're based on that you are deciding what to do next, where you want to move in next coming months or years. Up till now, do you have any questions for me? Okay, so let's move forward with the next section. Next slide. Now let's take one practical data pipeline wherein we want to see how we are actually collecting data which is generating continuously through, and then how we are connecting it to any visualization tool to see what is happening at current point of time. So when it comes to data engineering, again, I'm reiterating that we have different stages. We need to make sure that somewhere data is getting generated. We are collecting that data, we are processing that data, we are storing that data in data lake or similar kind of store, and then we are analyzing it. So in this case study, what I'm going to explain is that this is all about taxi trips, wherein whenever there is a pickup drop, there is a transaction happening, which is streamed to an to Event Hub, and we are reading data from that Event Hub, and we are actually storing that data into data lake store, and then we are running some ETL jobs to aggregate that data, to clean and then aggregate data and store it in some place wherein from where your analytics jobs or your visualization tools can connect to it. So whenever there is a uh, transaction, for example, a user gets picked up and dropped, once the transaction is complete, the transaction is sent to an event hub, and then those are getting stored in Event Hub. And as a data pipeline, we want to make sure that we are working on that data. So we need to make sure that we are collecting that data into some kind of uh, new logs wherein we can work on it. For example, if I go to if I go for data generator tool, you can see that when it comes to raw logs for April month, it creates folder. If it is not there, then it goes to month wise, sorry, day wise, and it starts generating data per second. This I have I'm creating this data here per second, but you can imagine that every microsecond or within a second you might be getting a lot of transactions from your servers, and each CSV file or each flat file will have some kind of data in it, and we want to make sure that we are aggregating this data. Before aggregating, we are actually cleaning this data so that we can we can have some uh, end process log wherein we can connect to it and we can get some get some insights out of it. So here you can see that in 5 or 10 seconds itself it created such a huge amount of data. Now go back to my so assume that this is the aggregator job which runs on top of this data, and it aggregates that data into one single file. And in doing so, it also creates new columns required for your data processing. So you here you can see that when your raw data is there, you have vendor ID, pickup date, passenger count, where from where he was picked up, latitude, longitude, and where he was drop off latitude, longitude details. Now, when we run the aggregator job, uh, what we are doing exactly is that we are actually aggregating this data into one file. So for example, now when we ran this, so we got all these transactions into one single file. So you can see that we got this file wherein we um, converted this. date time into proper date time format. And then we also added this new column weekend. Weekend, why you need this mm, new column? Because you want to classify whether if this taxi trip is from a weekday or weekend, so that you can analyze what is the peak time when it comes to weekend, and what is the peak time when it comes to non weekend type. So this is nothing but some kind of logic you write when you're configuring your ETL job. Um, Simplest thing is that simple code I would like to show here is that when you collect this data into one data frame, then you actually format this date time and then again store it back into your data frame. And now when you want to categorize that taxi, whether it was uh, weekend or not, you add you add additional column like weekend, and then you run some logic over there, and you decide whether it is weekend or not. In similar fashion, you can add different columns based on your user uh, scenario or use case. Now, when you create this aggregated data, right, you want to run some analytics job or analytic job on top of it. So you either you can send this aggregated data to some stored data lake, or you can go data, and then you connect it to Power BI. For example, if I connect this data to Power BI, I will come to know that during April. So if I connect to that data in April month at uh, 1 a.m. in morning, uh, this how many rides were happened. So you can see that 2000 rides happened, and that too in this area. There were some kind of outliers. For example, this is the location which is not near to this city. So this kind of data you can use in order to make sure that where you want to place your taxis, so that people are consuming that data, consuming those taxes for their rides. Then here again, if you go to 9 a.m., you can see that now that rides are doubled. So this is the basic visualization I added here. But you can imagine that if you want to share this thing with your stakeholders, uh, and you want to bring some new enhancements, you want to propose some new enhancements, how you can use that data in order to solve those. So so basically, your pipelines can be configured based on your applications. Uh, so it could be AWS, it could be Azure. You're streaming directly from Event Hub, or it can be streamed from Kafka and all that thing. Instead of placing that data into Azure Data Lake, you might want to use Cosmos DB, or when it comes to AWS, it could be S3 buckets, uh, S3, and then you are running some analytics jobs in either AWS, Elastic MapReduce, or when it comes to Azure, you're running analytics jobs using uh, languages like USQL and all, which again gives you some kind of insights into your data. So this is all about the different use cases when it comes to architecting your applications to solve your business scenarios using data. We saw the practical flow, how how the data is getting generated in seconds, and how we can aggregate, how we can create ETL job in order to clean that data, add additional columns if required, and how to connect that and see visualization through Power BI. We also saw that how business or stakeholders can decide whether to continue investment, whether to pause any investment based on the user journey while using that application. And then we saw some use cases based on the assignments we did here. And then defined from where we can generate this kind of data. With that, I conclude my today's session. If you have any queries, do let me know. We can have a couple of queries now, and later I can try to answer some of those tomorrow.
Shailesh, Vinay here.
Ah,
Yeah, I have some points about the data. Actually, we are generating the taxi data as means in schedules and making the aggregate, right?
right.
Can you show again means daily and aggregate data? How we making that? Means you are
Yeah.
taking some periodic data or real time data. I'm talking. Suppose
So I just wanted to give a feel of how what is the meaning of big data when it comes to big applications. So I just wanted to show that per second how this kind of transactions are getting generated and how it is important to aggregate first those data and then start running your analytics jobs, because you
correct,
cannot run analytics job directly on whatever data is coming, because you want to make sure that you have data full snapshot of that particular day. So in real scenarios, what happens is that we usually this aggregator jobs run next day, so that it covers 12 a.m. to 11:59 uh,
okay,
uh, I mean, basically covers one day full, and then it runs. Those aggregated jobs are running, so it waits for whole data to come arrive, and then for that particular day, and then it runs aggregated jobs to run to collect that entire data into one log file, and then you clean that data. You create based on your users scenario.
correct.
You extract typical. I mean, extract your data
Means
to for,
means you are taking the periodic data just for a demo, right?
just for a demo.
Okay. And you are making that data you are connected with the Power BI, right? Now to do the visualization.
Yeah, yeah, right.
Okay, thank you.
Okay, then let's meet tomorrow again. Tomorrow means next week. We'll come up with next set of topics for you all. We'll have something related to big data in next session. So with that, I conclude today's sessions. Thank you, all of you, to joining today's session.
Thank
Thank
you.
Yeah,
Yes, thank you, Shailesh. Thank you, Shailesh. Bye.
yeah. Bye.
Thanks, Shailesh. Bye. Ankit, how was it from on-site today?